Okay. All right, we will get started. Most people don't know this, but Krakow is actually one of my favorite cities in the world. If I ever make a new class or something, I always come here to teach it before anywhere else. But I'm curious, how many of you like to code? That's a good number of hands, and if you don't have your hands up, why are you here? So the talk we're going to go through today is going to be 100% just looking at code. How many of you have heard of event sourcing before? All right, most of the hands are up. You know, it was only like 7 years ago I would go around and talk about it and no one had ever heard of it before. What's interesting for me is when we start looking at event sourcing, almost always people are either doing it in Java or C#. And they do it in this weird, awkward, object-oriented way. When event sourcing at its core really belongs in functional code. It is a functional way of doing things. And if you write it in functional code, it will actually end up a whole lot simpler than your object-oriented code. In fact, if you go look at the object-oriented way of doing things, it obscures what's really happening underneath the covers. Now, what we're going to start off with here is a simple application service from domain-driven design. How many have written a piece of code that looks something like that before? This will sit on top of your domain model and basically coordinates the domain model to get work done. But there's a lot of problems that are hiding in just this little tiny piece of code because it's being done in an object-oriented style. And this isn't even really object-oriented here. And almost no one today will actually create something called an application service anymore. Today, people have moved on to other patterns, like, for instance, writing command handlers. And we end up with a big problem that happens in this piece of code. And I'm sure some of you have run into this before. This is a very interesting point cut in terms of how our system works. There is one of these for every use case that our system does. Now, when you have one thing that's per use case, you tend to want to put cross-cutting concerns on this. As an example, we could go through and we might want to say that this should be requires permission admin. For the Java people here, that's an annotation. How many of you have done something like that before? OK, so now on top of this, what we're going to end up with is a dynamic proxy. And dynamic proxies are wonderful pieces of code. They are horrendously complex, wonderful pieces of code. I would highly recommend reading the source code of one if you want to learn a lot. But have you ever tried explaining one to a junior? And what happens when the magic stops working? Like, what happens if we have a piece of code that does something really evil like that? What happens when you return this and you have a dynamic proxy wrapped around you? Well, you take the proxy off of yourself. And all of a sudden, that permission disappeared because I did a return this. You can run into a huge amount of complexity when you start doing this. But what we have to ask the question of, what problem is it that a dynamic proxy solves? And it's not apparent when we go and look at this code. Because in this code, I could just as easily go create a proxy for requires permission. But what happens when I have another one of these? And let's say that it's going to be down here, and it's going to be called reactivate. But reactivate doesn't take a GUID and a string. It actually takes an int, which is the count, and it takes an int, which is the user ID. How do you write one proxy that can hook a method named deactivate of GUID of string, and it can hook another method, reactivate, of GUID of int of int? You can't. And this is the problem that dynamic proxy solves. It allows you to hook methods of arbitrary name with arbitrary parameters and to give a common interface across them. In fact, when I go to look at what my dynamic proxy is going to pass to me, it's going to pass me a method info, and then it's going to pass me an object array, which were the parameters that were being passed. The only problem that it solves is me being able to hook multiple methods with varying names and parameters. And the parameters can be in arbitrary types. All the complexity that you bring into the project of hooking up a dynamic proxy, it all is to solve that problem. And this is a common theme we're going to look at during this talk. What if I were just to say that I don't have that problem? And then I wouldn't need my dynamic proxy anymore. And we could do that relatively simply. So let's just get rid of this really quick. And I am using a wonderful IDE known as Sublime. If you happen to be using IntelliJ or ReSharper or something that has a little bit of understanding of your code, what you would do is, this is a refactor known as refactor parameters to object. So what I'm going to do is I'm going to create a new object, which is going to be called a deactivate. And here we would use d.id. And here it's going to be d.reason. And then we're going to have a public class deactivate. And we're going to use my awesome Sublime refactoring tools known as my fingers. And we're just going to make these public for right now. Normally, I would want these to be read-only as well and put in a constructor around them. OK. How many of you think that was a hard refactor? Come on, there's got to be at least one that thinks it's a hard refactor. That was difficult. But what if I told you that refactor was basically where we're going to get all of our benefit from? That one stupid refactor of saying, instead of having parameters, I'm now going to pass an object. And in this case, it's not really an object, it's actually a structure. But what this allows me to do is it allows me to build a common interface across all those methods that were there, whether it's deactivate, check-in, check-out, reactivate. They all have a common interface now. Because what I can do is I can say that we're going to have an interface. We're going to call it message. And it's just going to be an empty interface. We're going to say deactivate is a message. And now we're going to create another interface, which is a handles of t. And have you noticed that .NET people always put i's in front of their interfaces? That's just weird for me. And I never quite understood it, and I've never gotten the whole backstory on it, because if you go talk to them, Hungarian notation they decided is really, really awful. But ICANN has cheeseburger is good. So we're going to have an interface, handles of t, which is going to have a void handle, which takes a t, which is the message that's being passed. And then we can come up here, and we can say this is actually a handles of deactivate. And of course, when we do this, we won't call it an application service anymore. We'll call this, I don't know, maybe a handler. And we'll make this a handler. But the thing is, now I have a common interface that goes across all of my handlers. Every handler I have is a handles of t. And this allows me to get rid of that whole thing known as a dynamic proxy. Because now what I can do is I could come up here really quick, and let's get some space, and I could say that we're going to have a public class. What's the quintessential cross-cutting concern? I guess logging would be it. So let's do a logging handler of t, which is a handles of t, and it's going to be a constructor, which is a logging handler, and it's going to take a handles of t next. And I really love object-oriented languages that they make you type the same thing so many times. So we'll say next equals next. And then, of course, here I'm going to have to say this is a handles of t, which is next. And then we're going to have a single method, which will be public void handle. And it's going to take a t, which is the message. And of course, I'm pretty sure all of you have done this. So we're going to say my super amazing logging framework that we spent 6 months on. .log message. To be fair, how many of you have built a logging framework? Yeah, there's way too many hands on that one. But now that I have this, I'm just going to use basic composition. And I could say var handler equals a new logging handler of deactivate, which will wrap a new deactivate inventory item handler. And cool. And I guess we'll pass an Oracle repository. And we will pass a new CA lookup. And cool, OK. We have now refactored, and we are now using command handlers as opposed to using application services. But this is a technical refactor. It's really, really simple. And we are still doing this in the idiomatic, object-oriented way of doing things. And I know in Java 8, you guys got these cool things called lambdas. So I'm going to give you a hint. There was actually a great slide. It was by Scott Vlashin last year at Build Stuff. And he had object-oriented patterns versus functional patterns. And so like he said, you know, if you want to do like what we're doing here, where I restrict access to an object, I use a proxy. And functional programming, this is known as a function. And then there was a strategy, which is also known as a function. And basically, he went through all the object-oriented patterns, and they all came back, and they were function on the other side. But with Java 8, now that you guys have lambdas, I'm going to teach you a secret. If you ever find an interface that has one method and only one method, and it literally makes no sense to put another method there, don't use an interface. Use a function. And when I go down and I look at my interface here, handles of t, would it ever make any sense that we would ever have another method on this interface? Like, what are you going to put there next to handles of t? Like, get name? Like, it doesn't make any sense to put anything else on this interface ever. So the rule is, if you start seeing this, at least think. I'm not going to say you should always do it. There are some differences between interfaces and functions. But if you have an interface with one function, try refactoring and just making it a function. So if I wanted to do that, what we would do is we'd grab this code here. And then we're going to put it here. Of course, now I have a problem. Those dependency things that we were passing in through the constructor are no longer here. Of course, I learned another way of doing dependency injection before dependency injection was cool. It actually came about in Fortran. It was known as parameters that you pass to a function, as opposed to doing it the fancy way. So let's try that. And let's grab our dependencies here, and we're going to pass them into this function. I know this is a very complex refactor, mostly for me because I'm working in Sublime here and I have to fix the indentation. Let's get rid of that. OK. Again, how many of you think that was a hard refactor? All I'm doing is I'm going to pass my dependencies to the function as opposed to going through and passing them through a constructor. Now, how many of you use a container today? Well, it looks like most everybody. OK. How many of you use almost exclusively constructor injection? Yeah, that's a problem a container makes you do. So one thing we have to consider is what is the granularity of the dependency versus the life cycle of the object? And I find very often people will have a dependency that they use in one method of an object, but they still pass it through the constructor, which is odd. You can also pass dependencies as parameters to a method. There is absolutely nothing wrong with doing this. So now we have our function, but we also introduced a problem, and let's get rid of that object-oriented code and make it go away. Our problem is that right now what we have is an action of I inventory item repository of I can look up license of deactivate. And we have a very similar problem to what we had earlier. And the whole reason we needed a dynamic proxy was because we lost our common interface. What happens when I have another method called reactivate, and it's an action of I inventory item repository of GUID of int? We've basically lost our common interface between all of our methods that we want to be able to call. It's the exact same problem that we started off with. And there's a couple options I could do here. We could follow the same pattern as what we looked at earlier, and I could refactor dependencies to object. And now every method is going to take a dependency object, and it's going to take a message. But that's not what we're going to do, because there's cooler ways of doing it. This is, in fact, a very common situation that you run into in functional code, where I need to close out some dependencies in order to be able to make a method more specific. And instead of doing things this way, what we're going to do is we're going to say that we've got, let's do a handlers.add. And now what I'm going to say is I'm going to open one of those funny things known as a Lambda expression. And I'm going to say deactivate with a new Oracle repository and a new CA lookup, and then I'm going to pass X. This pattern is known as partial application. And basically what we're doing is this little piece of code with the Lambda, it takes a function that has n parameters, and it closes some of those parameters by giving them values and returns a function with less parameters. We can look at another example of this really quick. So let's just say I've got an int add. And this takes an int x and an int y, and we will return x plus y. And then we're going to partially apply this. So we could say var, x, or let's call it add5, equals q add5q. And what we did was we took our function that has two parameters there, and we made one of the parameters always to be equal to 5. And we returned a function that now only takes one parameter to it. This is very, very common in functional code, and it's known as partial application. And all we're going to do is we're going to partially apply all of our handlers here. Because what we're trying to get is, before we had that we were using an action of I inventory item repository of I can look up license of deactivate, and I want to be able to convert this to something that is basically an action of deactivate, because if I have an action of deactivate, I can have a generic interface, which is an action of message. And this is what partial application is allowing me to do. It's allowing me to close out the parameters from the first action to get an action of deactivate, and then I can have my common interface, which is an action of message. And this is a different way of solving the exact same problem that we were looking at the beginning. By the way, for those of you who are interested in functional code, this is also how you do dependency injection in functional code. You use what's known as partial application. Have you noticed that if you go work in Scala, there's no dependency injection framework? No containers? This is what you're going to tend to do instead. And now I just want to add a little bit of code around this. And this is a very common thing that we're going to do in functional code. So let's just copy and paste this guy a couple times. And when you guys make services, how many methods do you normally have in your microservice that are public? Is it like 10 or is it like 55,000? Well, it being you're not supposed to go over, what is it, 89 lines of code in order to be a microservice, then you probably shouldn't have 55,000. But let's imagine we've got our microservice, and now we're going to put this in and we're going to call this reactivate. We may have another one of these, which is going to be called check in. And we may have another one, which is going to be check out. And we may have another one, let's call it audit, because that seems to make sense in an inventory context. And they don't all need to have the same parameters. For instance, maybe this one doesn't take a CA lookup. Maybe this one doesn't take a CA lookup, but it actually takes a new receipt generator. And maybe we have another one that takes some other parameters. They don't all have to be the same. And what I'm going to do now is I'm going to come up here and I'm going to type in front of this public void bootstrap. Now, when my application starts up, I'm going to call this method bootstrap. And bootstrap is going to wire up my system together. Do I need a container anymore? Or has my container disappeared here? So this is a big one. How many have had a bug in your code before? I know you didn't write it. It was the junior on the team that put it in, even if the junior was you yesterday. When you have a bug and you go talk to your boss, does your boss care whether that bug was in an open source project that you use or whether it was in your code? Or when he looks at it, is it just a bug that you need to fix? How many of you have gone and read the source code for your container? It's a lot of code, isn't it? And the problem is when you have this huge, vast amount of code, and it's really complicated code, really smart code, there also tends to be bugs that come out of that code. And they tend to be subtle bugs because lots of people have used that code before. Which is more likely to break? My code that's right here, or all the code that's in a container? I've come to the point that when I write something like a microservice, and when I need to feel the need to put a trademark every time I say that, I don't use containers for this stuff anymore. And I've had lots of people challenge me on this, and they say, yes, but here you're only using a singleton lifestyle. And what if I wanted to do one per request? And it's like, okay, well, I know how to do that too. Okay. Now we do one per request. And there are some valid arguments why you would not want to do this. And there are jobs that containers do really well that this code would really get horrendous on. Let's imagine, for instance, we have our Oracle repository here, and then we were to say a new, really screwed up TNS names provider. How many of you have worked with Oracle before? How many of you have upgraded Oracle and then wasted a day because it was finding the wrong TNS names file because it changed from one version to another? And it was one of the 75 random TNS names files you have there. So there we're going to get a real TCP connection manager, because what goes wrong there with a new TCP connection manager? And think about how much easier this would be right now and less painful if I were using a container. But you know what? Stop. I want you to feel the pain of typing that. And when you have 7 levels of nested dependencies for your repository, I want you to type them out manually. and I want you to think I'm an idiot and I'm doing something wrong with every single keystroke that you hit. Why do you have 7 levels of nested dependencies for a repository? There are places that containers are good, and they solve one problem extraordinarily well. And the problem that they solve is the problem of nested dependencies. But I don't want you to have that problem. And you shouldn't have that problem in this code. If you're going through building out a small microservice, you shouldn't have the problem of 7 levels of nested dependencies. If you were to go off and build Swing, then yes, that's totally valid, and that's really part of your problem. Here, if you're doing it, you're doing something wrong. And I really want you to feel the pain of what you're actually doing wrong, especially if you're using a TNS names provider, because that's just going to really ruin your day. But normally, when I'm writing this style of code, I don't like using containers. I will go through and manually do my configuration here. Now, there was a team I consulted with in Oslo, and they had XML configuration for everything. This is a very Java thing to do, I know. They, at the end of the day, had more XML code than they had Java code. Why? Because it needed to be runtime configurable. Until you went and looked at the XML, which had things like field names inside of it. And how many of you know a system administrator that knows all the field names of your software? So what was happening? They would basically write their code in XML, and they've managed to convince me XML can be a Turing-complete language if you mess around with it enough. So what will we do with this? Well, we're going to do this in a slightly different way. And instead, what I'm going to do is I'm going to ship a file with my software, and it has Bootstrap inside of it. And when my application starts, I compile that, and then I call into it. Now, if you want to edit my configuration is also this thing called a function. Remember we said everything in functional languages, you end up with a function? Yeah, well, my entire configuration is a function too. When you go to edit that function, do you still get IntelliSense support? Do you get refactoring support? Yeah, it's all built into your IDE. And you know what? You guys all seem to know how to code. So for me, the best thing I can give you for how to configure me is probably code. And this is a really common thing to do in languages like F# or Lisp or Scala. It's very common in functional languages that I give you a piece of code like this bootstrap method. And we don't use things like containers. But we're ways off from becoming truly functional in this code. So one thing that I don't like is this void. It's going to cause me problems. And the problems I'm going to find, you can start seeing when I go and I think about how I'm going to test this method called deactivate. So if I wanted to write a test around deactivate, I would pass in what? Like a mocked repository? And then what I'm going to do is it's going to call getById, it'll call item.deactivate, and to be fair, we're probably hiding a line here, which it would be, and this should be not underscored. And here we would basically have repository.save item. So now in my test, what am I really going to be doing here? So let's just imagine we have a public void does deactivate. And in here, what am I going to do? I'm going to say something like deactivate, and we're going to pass my fake repository, and we'll just say we've got a mock lookup. We'll imagine that comes from someplace. And here we're going to say var fake repository equals a new fake repository of inventory item, and we'll pass in our item, and here we'll say var item equals a new inventory item, and I guess we'll give it an ID of 12. And do you guys like making funny data in your tests? I always do. So we'll call it like razor blade ice cream, because that sounds tasty. And then down here, we're going to end up doing something like assert that item is deactivated equals true. But this is a really weird way of doing my testing. It's got these weird dependencies out on repositories and mock objects, and these kinds of tests, they get really brittle really fast. And there's another way of doing this. What if instead of doing things this way, I were to here say return item get uncommitted changes. And we'll look at what that method does in a couple minutes. And now, instead of returning void, we would say this returns an IEnumerable or a list of event. And now all my handlers will actually return a series of events directly. As opposed to dealing with a repository themselves, they return me a series of events, and then I can push those events off into something in order to save them. And I can do that at a higher level. And we know how to do this at a higher level because here we can use basic composition for it. Let's go and try writing a little composable piece. We did logging previously, so we're going to have a public void log of t, which takes a action of t, we'll call this next, and it takes a t, which is its message. And then we'll say my amazing logging framework that we only spent 3 months on. .log message. And then we're going to say next, and we're going to pass our message. Now, if I wanted to add a compositional piece up to one of these, we could, for instance, we could say q is equal to log of deactivate, which its first thing is going to be the function that gets passed to it, and the second thing way back here is q. Now, you can imagine how ugly this looks after we have 3 or 4 of them there. And this is why there's a beautiful operator that is in many functional languages. It's known as a pipe operator, where I might say something like we have receive. And receive will go to log. And log will go to deactivate. So when you see something like this on the front of my laptop, that's what that's talking about. It's known as a pipe operator. And what we're doing is just the same thing as what this code here is doing, where we're calling a function and then passing a function and then passing, and we're calling down a chain or a pipeline. Most functional languages will allow you to do this directly. Another slight difference with this code is here we're putting this thing into something called handlers. Handlers is basically a dictionary based on type to a handler. So when I get a message, I can look up based on the type of the message, and I can get the handler for the message. If you were to do this in a functional language, you would probably use a pattern match for this. And you'd just use a pattern match directly. You wouldn't use something like a handler. We'll talk more about that when we get into projections in a few minutes. So now we've got this log of t, and we're now returning back series of events. How hard would it be to test my method deactivate here, which returns a series of events? Would this be difficult? You pass in a repository and a lookup. It passes you back a series of events. It'd be a whole lot easier than trying to get like a test working with like the repository where I'm asserting off the item that I have to put in the fake repository. And we'll start seeing this when we start looking at functional code, as it tends to be much, much easier to test. But we're still not functional, are we? still have that object-oriented domain model getting in the way. But we've built one of our core building blocks here. And one of our core building blocks that we're going to look at is when we talk about a command handler. A command handler is function that takes state and a command, and it returns events. That's all this method down here is doing now. It takes a bit of state, it takes a command, and it returns a series of events. But it's still doing that in an object-oriented way, because right now item is still an object. And we can go look at item, because item actually lives over here. And we can see item is a class, which happens to be an aggregate root. What it is, though, is it's an object that's encapsulating a bit of state. And when you call this method here deactivate, what it does is it does some checking to see if it's allowed to transition to a different state. And if it is allowed, then it calls this thing apply change. And apply change is actually implemented here in the base class. So what does it do? It calls this as dynamic.apply event. And funny thing about this code, and this code is actually on my GitHub if you want it. If you come in and you look at simple CQRS, there's a file here. I don't know if you guys can read it or not back there. It's infrastructure crap, don't bother reading, it's not important. What do you think the first file everyone opens is? And what's in that code is the thing that allows me to do this. And basically what that does is that calls a private method on my derived class with best matching. Yeah, that's some interesting code there. It's weird. But what will happen is it calls up into this apply method here, this private apply, and then in this method we set what the state actually is. And for me, a lot is actually being obscured in this whole process because of the fact that we're using objects. Another example of this can be seen if we go look into our read model. And this is a very common thing to do. What we have here is a projection. And in the first one, we have an inventory list view. And you'll notice that it handles an inventory item created, it handles an inventory item renamed, it handles an inventory item deactivated, and then it has these handle methods that are there. What this is used for is when we replay back over an event stream, and we want to build out a read model. And there's a piece of code that wraps on top of this, and what it does is when it sees an event, it calls into, let's say, inventory item created, it calls the handles inventory item created. And it does this through reflections magic. Or maybe it does it basically the same process through really, really reflections magic, because you guys know it's always a good idea to call a private method in your derived class, right? What could possibly go wrong with that? But in both of these cases, what's really happening here is our object orientation is obscuring what's actually going on. And we don't really see what's happening in the code. So if I were to take this method, and how many parameters are being passed to this method? How many think there's one parameter to this method? How many think there are two parameters to this method? How many think there's three? How many are just not sure? Okay, so there are two parameters to this method. Whether we talk about C# or Java, there's either time, there's this wonderful parameter here. It's going to be an inventory item, this. But because it was an instance method, we were going to forget about that, right? And we will just access this as mutatable state, and it will be fine. What could go wrong? So what I want to do now is I want to grab this method out of here. And let's just move it up and give ourselves some space. We've already said that method was really the equivalent of a static method that had an inventory item and the event that was being passed to it. And it would mutate that object called this. How many have heard that mutation is bad and you should avoid it if you can? Yeah, because it causes like concurrency problems and bugs. And so what if I were to do this? And we'll make this return an inventory item. And then we'll imagine that here we would say like a return, and I don't like calling it this anymore. I would never name it this. Why don't we just call this like state? Then we'll say like state dot clone with, we'll do it this way because we like object-oriented stuff. Activated or dot deactivated. Or we could do return a new state, and we'll pass in, or sorry, new inventory item, because that's what we called our state. We'll pass in state, and then we will basically say activated equals false. And that goes here. How many of you consider that to be a big change? All we're doing is we're saying we're not going to mutate the same thing every time. We're just going to return a new one. It's the only difference. And instead of putting all of my methods in the thing, I'm going to have a thing and then some methods. The code itself doesn't really change. But we've now entered into immutable land. And this works the same whether we talk about these read models with these handle methods. And by the way, as you can see here, this is using MongoDB. But we have only refactored slightly so that instead of mutating one thing that's passed to us, we return a new thing as opposed to mutating the thing that was given to us. And this is going to be the basis for our entire model and for all event handlers in our system. Every single function will work exactly this way. And when we talk about these, what we have is a function that takes state and event, and it returns state. This works for every projection in your entire system. This works for your entire domain model. Basically, what we do is we have a function that is given a piece of state and an event, and it returns a piece of state. So let's look at what would happen in a situation. Let's imagine that we have an inventory item created. And then we had an inventory item. All right, I'm going to shorten these. We'll do checked in, we'll do checked in, and then we'll do checked out. And then we'll do deactivated. Now, if I were to go look at that projection and object-oriented code that we were dealing with earlier with MongoDB, what I see here is I basically see this code is reacting to an event stream, where it has these handles methods, and based on the event, when I get my events coming through here, when I get created, I will cast that object to a handles of inventory item created and try calling it. When I get checked in, I will cast it to a checked in, and I will try calling into that projection. Once I start moving to a series of functions like these, it doesn't work that way anymore. And I can't just cast my object with reflections and jam things in. Instead, things change a bit, especially since we're not mutating one concept along the way. So for instance, here I would have my created. And we said before that every function, it takes state and an event, and it returns state. So what are created's parameters? Well, what's my state before I get created? It's my first event. Null is an acceptable answer. I would also accept an answer of maybe we'll call it a function init which gives me some state to start with, some initial state. In particular, if you're using languages like JavaScript, this is really, really useful to have, because otherwise in your handlers you keep testing if this thing already exists, because you don't have any way of specifying it from the beginning, so it always exists. And then we'll pass an event to it. And then we have checked in. And while checked in is going to get passed a return value of created, which gets passed in it and its event. And then we have checked in, which gets passed a return value of checked in, which gets passed a return value of created, which gets passed a return value of init. And then we have checked out, which gets passed a return value of checked in, which gets passed a return value of checked in, which gets passed a return value of created, which gets a return value of init. Oh, these get long after a while. And then we have deactivated, which gets passed a return value of checked out, which gets passed a return value of checked in, which gets passed a return value of checked in, which gets passed a return value of created, which gets a return value of init. And dear God, that's the end of it. But this function chain basically represents, with my functions that are now returning state, how I would write a projection. And I just want to edit this code a little bit just to make it a little bit nicer to look at. Because to be fair, that line of code is really painful. Ah, there we go. That's starting to look better. Has anybody ever seen a pattern that looked like that in code before? It's also known as a left fold. And this is a higher order function in any functional language you're going to deal with. Basically, when we talk about this, what I want to do is I want to write my functions so that each function, it takes state and an event, and it returns me state. I then put another function on top of that, which will do a pattern match for me. And it will call the right function based on the type of event. Now, you can even do this in Java. It'll be a series of if statements or a switch statement. Switch statement is also known as the most horrific pattern match ever built. And basically what you would do is you would say created, we want to map created to a function that knows how to handle created. When I get a checked in, map a function to checked in. All we want to do is we want to basically customize this left fold that we're looking at here. And for this, I want to jump really quickly. I'm going to move to JavaScript, because JavaScript has a really simple way of doing a pattern match. We might, for instance, say created, and this maps to a function state event. Return, I don't know, let's call it count, s.count plus 1. Other words, what we're going to do is we're going to map this type of event to this function. And this is one way that we could actually express that. When we go and look at code like this read model here, how many of you would have understood that what's really happening here is a left fold with a pattern match? No, you want to go write a framework for how to do the reflections magic in order to hook up this thing with these handles of T interfaces and bring it back. But once I express it like this, you already have a framework. It's called fold L in any functional language that you're going to deal with. And your need for a framework completely disappears. All it is a pattern match on top of a series of functions. It is not a very difficult concept. And all of my functions receive a function of state and event, and they return state. The little bit on top of it, it takes events, runs that fold, and returns me back a bit of state. By the way, does anyone remember what our other one that we defined was? It was function of command. All right, I'll make it this way. State, command, and it returned events. That was our command handler. So what do we pass as state to our command handler? We pass the function of events that returns us back state, which calls the left fold, and then basically handles with our functions that take state event to bring us back state. And then we return a series of new events that we write back. How many of you have seen this little cute dragon before from Event Store? So he's kind of like our mascot. If you actually look at our real logo is basically a circle with some arrows getting bigger around it. What it actually is an Ouroboros. An Ouroboros is a dragon or a snake that's eating its own tail. This is why that logo is actually there for Event Store. What's happening here is I'm basically coming through, I replay off my events through a series of functions defined by a pattern match that returns me back state. I then take that state plus a command and I drop it into a function that returns me back a series of events, which then I add back to my list of events from my previous bits. So what happens when I run again? Well, now I've got those new events. And I only need to replay those new events. And basically my list of events gets bigger and bigger, and these functions basically just build a big circle around each other. And this is why the logo is an Ouroboros. This entire model we've been looking through, and I know a lot of you guys have probably seen off in object-oriented code people doing event sourcing. The entire model of event sourcing is actually inherently functional. It's not object-oriented. And when you start trying to implement it in a functional style, you'll start seeing that all your code just starts disappearing. And you'll never have a need for going through and playing with something like an event sourcing framework. Because all that you really need for the framework is a series of functions, a pattern match, and a fold left. All the other code just disappears. And I really wish that I had brought a slide deck with me, because I wanted to put up a slide from South Park of, and it's gone. But when you come and you actually look at this in a functional way, you will find that all your code disappears. These tools that you have spent so long learning, they disappear too. And I've had people ask me, like even when we were looking at the command handlers over here, why do I do it in this way as opposed to doing it in the idiomatic object-oriented way? And I can show you really quick. It comes into another question people ask me a lot, which is why do I use Vim as my primary editor? And like, how can I do that working in like Java and C# code? I mean, can you imagine working without ReSharper or IntelliJ? That'd be awful, right? And the reason I do it this way is pretty obvious when you put the code next to each other. I mean, just look at the two pieces of code as they sit next to each other. I mean, given my team spent 3 months longer writing the other amazing logging framework, but the code, it just disappears when you start doing it in a functional style. Let's go take a look at the command handler. And to be fair, this actually needs one more line of code in it that we added later, which was repository.save item. And think to yourself which of these you would rather be typing. And how many of you use IntelliJ or ReSharper today? How many of you feel slow if you don't have it anymore? How many of you have measured if you're actually slow or not? I measured. And I found using such tools, they actually broke down to be less than a 1% improvement. I used to be that guy that would actually sit there and do brown bag lunches where we would memorize keystrokes and learn new features of how to use the editor better, and since then I realized it's less than 1% improvement. To be fair, how much time do you spend typing versus how much time do you spend thinking? That's a really good question to ask. But there's another thing here. When I write code in a functional style, my need for such tools goes away. The reason you're faster typing the inventory item handler as when you have ReSharper or IntelliJ is because you're repeating yourself over and over and over again. And it will help you not repeat yourself. You can hit like Alt-Enter, create the field for you with the right type. And what about in the functional style code? How many times am I repeating myself there? 0. And your tools won't help you anymore when you start writing the bit of code on the second way. And it's the same thing when we look at log here. How many times do I repeat myself inside of this logging handler? How many times do I repeat myself in this code? You'll start finding that it's not just a matter of getting rid of tools like your containers and your dependency injection frameworks and your dynamic proxy. It's also a matter of you need far less tooling to write this style of code. And something like Vim will actually work quite well for you. And with that, I will just summarize that what we've basically done is just slowly refactored away from an object-oriented model and back to just these 3 core functions. And there's only 3 of them. And if you can bring it yourself back down to these 3 core functions that you're dealing with, everything else will just fall in place for you. And you have gone from being an idiomatic object-oriented model to an idiomatic functional model. Everything that we've done here is now purely functional, and your data storage as well is also a functional data storage. Everything in your system has become immutable. Everything in your system is purely based on transformations. And if for no other reason, you now know why our logo is a dragon. And thanks.